it's Presley at ActOutGames.com here, and today we're going to be doing another chemistry vlog, which we actually haven't talked about here yet, so.
Yeah, a little bit. It's been a while since we did one. So we want to wrap up our periodic table talk. I think this will be the last one where we really talk about how the periodic table works, and then after this we can talk about what it all means. But for now, I think we'll start just with the periodic table. So hopefully, if you've watched Presley's other vlogs, then you understand these, you know why these are here and how we've done these before to talk about how the electrons fit into the atoms and how they go into the outer shells and the inner shells and things like that. Up here, I've added, it's kind of a simplified periodic table that demonstrates a little bit of what I wanted to talk about why it's called the periodic table, the periodicity, and then a little bit about how the outside shells work in a little bit strange way. Just so you know what this is, this simplified table. This is sort of the periodic table we all know and love. So what I did is I took this center section here and got rid of it so that it's just these. So if you look at that on the periodic table, it just takes that middle section and collapses it a little bit. You can see that's the same shape as what I've got here. And this is 8 atoms across, and then it's actually numbered there. So you can see it goes all the way across. That's because, again, the most important thing in determining how an atom reacts is the number of electrons in its outer shell. And you'll only end up with up to 8 in its outer shell for reasons we'll see here in a second. I know we've talked about how there can be 18 or the different numbers that fit into a single shell in different orbitals, but the outer shell will only have 8. So that's sort of what this box indicates, right? So in the first shell, you've got the one orbital that has 2. The second shell on will have multiple orbitals. But oops, this one actually shouldn't be here. I did that again. I did that same thing last time.
Yeah.
So the second shell can have these 2 orbitals for a total of 8, and then the third you have these 8, and then you add these,
have that.
the D and Fs. So you can kind of continue to grow and you can have more, but every atom really wants these 8s to be full. That's the main thing that you can think about when you're trying to understand how things chemically react with each other. That they want those 8 to be full. The others don't matter as much, and again, you'll see why here in a second. And again, this is why there's 8 here. So you can always think of these as the number of electrons in the outer shell. So, or it can be full. So you have, 1 in the outer shell, 2, 3, 4, 5, 6, 7, 8, and when it's 8, it's full. And so these don't react very much. These that only have 1 react a lot with these that have 7, because any of these that make a combination of 8 that fills up that outer shell, you can get a good reaction with. Or any other way. There's many ways that they can fill up that 8, but that's what they want to do, is fill up that 8. So that's the important thing to understand. And these columns, so all of these atoms, or these elements that have 1 electron in the outer shell, they behave very similarly. They behave in a similar fashion because, that 1 electron in the outer shell helps define how they react. So even though they're different and they weigh different, why do they weigh different?
They're different because they have more protons.
Protons and neutrons, that's right. They have their nucleus is heavier. There's more protons and neutrons, but they still have that 1 electron in the outer shell, and that really defines how they behave. And so that's why it's called the periodic table, and what makes it periodic is that it repeats. You go 1 through 8, and then 1 through 8, and then 1 through 8, and they all just kind of repeat the way that they behave. So that's how it got its name. The only weird exception that we're going to start off with.
The Mongols.
The Mongols are always the exception, but in this case, helium and hydrogen are the exception, because in 1 you only have 2. So it's either it has 1 in its outer or it's full, and that's why it kind of jumps way over here. So let's go ahead and walk through building this out a little bit so you can see what I'm talking about. So if you remember here, we build this out, and this tells us how to put the electrons in. So the first thing that fills up is 1s. So that's 1 here, and that's this, number 1. This one here is number 2, and it doesn't go into this 2 box because it fills up the outer shell, so it actually goes here. That's why these 2 little things stick up off of the top, right? It would sort of make sense for it to go here because it has 2 in its outer shell, but the way it behaves is more like these because the outer shell's full. It doesn't want, the difference is these, when we get down here, this one wants 6 more to fill up its outer shell, so it behaves in a certain way, whereas this guy doesn't want those 6 more. The helium doesn't want 6 more to try and fill up its outer shell. So it behaves very differently, and that's why it lands in this column. You know, that's kind of how these will react. So if we come back and keep going, we go to 2s. You have a question, sweetie?
Is the way it acts here relevant to why it makes your voice really high or squeaky?
Oh, you mean like breathing in helium?
Yeah.
And the way that, yes, it is. Well, it's really its weight. It's what responds more to that and how dense it is. We'll do some experiments where we'll do one thing that makes your voice high and one that makes your voice really low.
I actually don't know anything that makes your voice low.
Well,
Except for my vocal cords.
You'll learn about it and you'll learn why it does that. We'll do a cool experiment on that, and that'll make a neat vlog to do that. That's a fun thing to do. It's a good question, though. So, again, so we go down. The next one, this says that we're going to fill up 2s first. So number 3 goes here, and that fills up here. Because if you see, it has 1 electron in its outer shell. The next one goes here, which is number 4, and it goes here because it does have this next p orbital, so it wants to fill up these 6 before it goes, and so you'll fill up 1, 2, 3, 4, 5, 6 more. So let's do these, 2, 3, 5, 6, and then see, it gets to the end, and we start over, and then when you come in, let's go do this, P, 2P, and then 3S. Once we filled up 2P, we come down here and we start over again. That's why the period starts again, because 1 and 2 go right here. And you'll notice, as we're filling these out, these 1 and 2 are always the S orbital, and these next 6 are always in the P orbital. And that's just how this thing fills out. So now we've got 1 in the outer, 2 in the outer, and we come back and draw again. We get 3p, so we fill up these 6, 2, 3, 4, 5, 6. You can see these. And you can see here that it looks like you're going to go on and fill up this d orbital, and so it's going to have more than 8. But if we follow our pattern, you see what happens here is that you go to the 4s next. So you fill up down here, and so now you do another 1 and a 2, right? Which you see how these things kind of fill up. And then this is what, when we built the, when we folded this in, these that are sitting in here that kind of went away, we're about to talk about those, because you'll see there are 2 in the outer orbital and 4 right here that we filled these up. But when you start following our pattern, the next one that gets filled up is 3D, which is this one up here. So now there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And all 10 of these still have 2 in their outer orbital, right? Because this is not the outer orbital anymore because we moved to 4. So these all really fit right here. They all have 2 in their outer orbital. Mm-hmm. And so that's why when you look at this periodic table, you can see that starting on the 3rd row, these 10 get squeezed into here. And the way they draw the periodic table, it makes it a little bit confusing because really it is kind of like this. They all sit in one place. And there are other little 3D representations of the periodic table that I think are better. But you can think of all of these actually have 2 in their outer orbital, just like this guy does. There's no difference between these. And then this next one that comes up, because when you go to 4P, you do the same 1, 2, 3, 4, 5, 6, and you get the next row. 1, 2, 3, 5, 6. So you can really think about kind of sitting right here in between these 2 are 10 elements that are filling up this D orbital. And then the next row will have the same thing. When you come back and you go to 5S, then you fill up 1 and 2, and then you'll come back and you'll catch these 10 here, and they'll sit under these 10. You know, where you see these rows, you get 10 more stuck in there. So you could go through and sort of continue filling out the periodic table this way, and you could see how these things work. And then when you get to, and you start filling out these, the F orbitals, you'll see that that's these guys down here, and they stick in exactly the same way. They kind of drop in, and so now you've got 2 in the outer orbital, and you've got the 10 that come in, but before those 10 come in, you've got these 14 that squeeze in on the bottom down here. So you can kind of see the structure of the periodic table as you do that. But the easiest way to think of is it's all about the number of electrons in the outer shell, and this is the easiest way to look at it, is that it just keeps repeating over and over these 8 1, 2, these 2 and these 6, these 8 are what these electrons want to pull back together every time they do it. It's just that as you structure these out, every once in a while you'll have a layer that has 2 in the outer orbital and suddenly it has 10 that it has to fill up, even with those 2 in the outer orbital. And the next time you come through, you'll have 14 that still have 2 in the outer orbital, and then 10 that still have 2 in the outer orbital, and then finally you'll come back and do those 6 that fill back those 6 up in the outer orbital. Does that make sense? It's a little confusing, but
it's not as confusing when you draw these lines to show.
Yeah, when you draw the lines that show how you fill them in, and then like I said, I like the periodic table like this, and then you can think of these 10 that sort of live down here. They kind of fill out this box. So, I would, when you're drawing it the way these are pulled out, I would pull this whole box out too, and then this box, they sort of nest inside of each other. But the periodicity of the periodic table happens with these 8, and these are the only 8 that, really make a huge difference in the way that they that respond chemically. And I've got a really cool, maybe we'll do one other little vlog, I've got a cool little cutout 3D periodic table that you kind of fold in, and it makes loops and stuff like that. And it's a better representation of what the periodic table actually looks like.
Than this.
Yeah, like this one. But like I said, the best thing to do is just keep coming through and drawing out what these tables look like. So now that you've done this, you can come back and grab these. And the more you get an understanding of, even though I'm growing electrons and I've just added 10 new electrons, the whole time this was the outer orbital, and there were only 2 in the outer orbital as I was filling that back up. And then, like I said, later when you get down here, you'll have these 2 as your outer orbital, and you'll fill up all 14 of these, and then all 10 of these. So you're filling up 24 electrons in a row, but never changing the outer orbital because there's only 2 out there. And that's what makes the periodic table a little bit confusing when you first start looking at it and you see these sections and these layers and things like that. But really simplifying it and just saying it's all about these 8 electrons in the outer orbital. And every once in a while you get in these little loops where you have to go back and fill stuff up, but you've still only got 2 electrons in the outer orbital. And that makes it'll make a lot more sense when you build it this way. Any questions? Anything else you want to add?
I want to add that in most of these vlogs, I'm actually sitting on something like these 2 pillows I have here, because I'm tiny without them.
She needs a little boost every once in a while so we
Yeah.
can be closer to the same height. Cool.
That's why I sit on 2 pillows.
Is that good?
Yep.
Okay. John A. Toy Day.
Bye.
Bye, everybody.